بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضة لغات، أهلا بكم. اليوم قانون نيوتن الأول. طبعا احنا عارفين إن نيوتن عالم كبير عمل طفرة في علم الديناميكا. طبعا هو اخترع قوانين كتيرة جدا ساعدت البشرية في ازاي تقدر تحسب حركة جسم لو انت عرفت معلومات عنه عن طريق المسافة او السرعة او العجلة. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson. It's titled First Newton Law or Newton First Law. My dear student, look at introduction about Newton First Law. My dear student, at the first, what is the type of forces? Nuclear, magnetic, electronic, gravitation, mechanics. My dear student, first law of Newton say everybody preserves in state of rest or of moving uniformly unless acting open by an unplanned external force by an external effect. My dear student, first law of Newton say everybody preserves in a state of rest or of moving uniformly unless acting open by an unbalanced external force by an external effect. My dear student, look at the remark. The body at rest preserves at rest unless acted open by a force to move it. Anybody at rest preserves with this case at rest unless acting open by a force to move it. And this body in uniform motion preserves at motion unless acting only open by a force changes its motion. The body in form motion or in rest preserves at motion unless acting open by a force change of its motion. Number 2. Information of the law, the expression force means the resultant of all forces. Force mean resultant of all forces which acting open the body. The force is measured by the Newton unit. The law of Newton, the two states of rest and uniform motion, is natural state of the body. When resultant of force acting in a body equals what? Equals 0. Number 4. The law show the body which is at rest or moving uniformly in a straight line. Eternal principle. Every body, as much as in its state endeavors to preserve its present state, whether it be of rest or of moving uniformly forward in straight line. Force acts, the effect which changes or tries to change the state of the body of the rest or of moving forward in straight line. Look at the first example. My dear student, in the opposite figure we have body this body at rest and a system of forces acting on it. The body at rest, there is an equilibrium. The vertical force must be equals down forces. Also, the forces in horizontal right equals the forces left is in an equilibrium, or the body at rest, this is in equilibrium. Sum of the forces up equals sum of the forces down, sum of the forces right equals sum of the forces at left. Find F1 and F2. Look at, my dear student. In vertical motion, F2 plus 40 equals 70. Then F2 must be equal 30. In horizontal, F1 at left, F2 plus 20 at right. Therefore, my dear student, look at the solution. Look at the graph. The body is at the rest state. The vertical are in equilibrium. Therefore, F2 plus 40 equals 70. F2 equal what? 30 Newton. My dear student, look at horizontal forces, also are in equilibrium. Therefore, F1 equals 20 plus F2. Therefore, by substitution, F2 equals 30. Therefore, F1 equals 50 Newton. Another example. Look at in the opposite figure, my dear student, body moves horizontally, moves in the direction down with uniform velocity of magnitude 8 meters per second. Find F1 and F2. Look at, my dear student, the solution. Look at, my dear student. The body is uniform motion state. Uniform motion state. Uniform motion means the horizontal are in equilibrium. Uniform motion. Uniform motion means equilibrium in horizontal. Thus, we reduce that to F1 plus 90 equals 300 plus 120. Therefore, 2F1 plus 90 equals 300 plus 120. Therefore, find the value of F1 equals 165 Newton. The vertical are also in equilibrium. Therefore, to find the value of F2, write equation 240 plus F2 equals what? 400. Therefore, F2 equals 160 Newton. My dear student, look at another example. A train of mass 200 ton moves under the action of resistance proportional of the square of its velocity. Train of mass 200 ton moves under action of resistance proportional of square of its velocity. If this resistance is 9.6 kilogram weight per ton of the mass of the train, when the velocity of the train is 72 kilometers per hour. Find maximum velocity for the train if the engine of the train can enter pull it with a uniform force of magnitude 4.32 ton weight. Look at solution. We have resistance R1 9.6 each ton. Then resistance is mass 9.6 times 200 equals 1920. Then V1 equals 72 km per hour. Let resistance R1 when the velocity V1. R2 resistance when the velocity V2. The resistance is proportional to square of the velocity. What is the rule? Excellent student. R1 over R2 equals V1 square over V2 square. Therefore, the train reaches the maximum velocity when the resistance is completely equal to the force of pulling the train. If V2 is maximum velocity for the train, R2 equals 4.32 ton weight. Therefore, multiply by 1000 to convert to kilogram weight. R2 resistance of R2 4,320 kilogram weight. Since R1 over R2 equal V1 square equal over V2 square, resistance are proportional with square of the its velocity. By substitution, 1920 over 4,320 equals 72 square over V2 square. By using cross multiplication, V2 equals 108 km per hour. In this case, the relation R1 over R2 equals V1 square over V2 square. From the given, the resistance are proportional with velocity of the train. Another example. My dear student, parachute lands vertical as the parachute is open. If the total weight of parachute and equipment is 90 kilogram weight, and the resistance is proportional to the square of its velocity, and longing maximum velocity of parachutist is 15 km per hour. What is the required? Find air resistance of parachute when his velocity is 10 km per hour. Look at the solution. My dear student, look at the opposite figure. Parachute reaches to landing maximum velocity when the resistance is equal to the weight of parachute and his equipment. Look at R1 is the air resistance, V1 velocity of parachute. Therefore, R1 from given 90 kilogram weight, V1 15 kilometer per hour. R2 is the air resistance when the velocity of parachute is V2. What is the relation between R1 and with R2 and V1 with V2? R2 unknown, V2 10 km per hour. What is the rule? Excellent student. R1 over R2 equals V1 square equal V2 over V2 square. Resistance is proportional with square of the velocity. R1 over R2 equals V1 square over V2 square. Therefore, by substitution, 90 over R2 equals 15 square over 10 square. By using cross multiplication, R2 equals 40 kilogram weight. Another example. Body moves in a straight line under action of three forces. F1, 4i plus 3k. F2i plus 4j, negative 15k. F3, such as its displacement vector s, is given as a function of the time by the relation s equals 2ti minus tj plus k. What is required? Find magnitude of the value of F3, the third force. Solution. Since, my dear student, displacement s equals 2t I minus tj plus k. Velocity, what is the velocity? We find differentiation displacement respect to 2 times t equals ds over dt equals 2 I minus j, or order the pair to negative 1. Acceleration equals dv over dt equals what? Equal value of acceleration dv over dt equals 0. Why? Because the constant 2 is constant. Differentiation of constant is 0. Then we have value of velocity 2i minus j, and we have value of a equals what? Equals 0. Therefore, the body moves with uniform velocity of magnitude square root 5 velocity unit. Therefore, F1 plus F2 plus F3 must be equal to 0. Substitution about F3 and left hand side equals negative F1, negative F2. Therefore, F3 equals negative 4, 0, negative 3, 1, negative 4, 15. The value of F3 is negative 3i, negative 4j plus 12k. By using magnitude square root, negative 3 power 2, 9, negative 4 power 2, 16, 12 power 2, 144. Then the force, the third force is 13 force unit. My dear student, the third force is 13. The third force, we know that F1 plus F2 plus F3 equals 0. When in this case, the motion in straight line is in uniform motion with F1 plus F2 plus F3 equals 0, we deduce that F3 equals negative F1, negative F2, equals negative 3i, negative 4j plus 12k. But in this case, the magnitude of the force equals square root coefficient of I square plus coefficient y square plus coefficient k square equals square root 169 equals what? 13. Then the third force is 13 force unit. My dear student, this example is very important. We have three forces acting at a body. Three forces act at the body. The resultant of three forces must be equal 0. Why? Because the body moves in uniform motion. Uniform velocity means is an equilibrium. Uniform velocity means the body is in equilibrium. Then we deduce that sum of all forces must be equal 0. F1 plus F2 plus F3 equals 0 by using equation to find the value of the third force F3. My dear student, the first Newton or Newton first law is very important. It's clear that any body in state or uniform motion don't change or not change from its case unless the effect of natural body effect on it. If we have a car, this car is in equilibrium. Is in equilibrium in two cases. If the car in state means is equilibrium. The effect of any body, no effect of any body. Therefore, if the car moves in uniform motion means is an equilibrium also. We have forces in left hand side or up and down, right and left. The vertical forces must be equal. Also, horizontal forces must be equal. Why? Because the body is in equilibrium. Any body in equilibrium means vertical motion or vertical forces are equal in magnitude, opposite in direction. Also, horizontal forces are equal in magnitude and opposite in direction. Then we deduce that from the Newton first law, any body in state or in uniform motion or uniform acceleration or uniform velocity unless the natural body effect on it. My dear student, this rule we use in our life in more cases. If this body moves in a straight line, this body moves in a straight line with uniform motion. With uniform motion, if the force act on it, this force in horizontal on a straight line. This force change the case of the body. Why? Because there is natural body or other natural body act on this car. Then the first Newton law say any body is in equilibrium in state or uniform motion unless a natural body effect on it. My dear student, look at the following example. A body of 120 kg is pulled by a rope inclined to the direction of the motion with angle of tan equals 3/4. To move the body with uniform velocity, if the tension of the rope is 75 kg weight, what is the required, my dear student? Find first total resistance of the motion. Second, find the vertical reaction of the plane. My dear student, look at the solution. The body moves with uniform velocity. What do you mean? R equal 75 cosine theta. Therefore, we have from given tan theta equals 3 over 4. Therefore, cosine theta equal 4 over 5. Find R. R is resistance equals 75 cosine theta equals 75 times 4 over 5 equals 60 kilogram weight. N plus 75 sine theta equals W. The second equation of the motion N plus 75 sine theta equals W. We know that N equals W minus 75 sine theta. Value of N equals W 120 minus 75 times sine theta equals 3 over 5. Answer is 75 kilogram weight. Therefore, N equals 120 minus 75 times 3 over 5 equals 75 kilogram weight. Look at, my dear student, the opposite graph represents the example. My dear student, by the end of the lesson, we know that the first to know Newton law, very important to use in more cases in our life. My dear student, I am very happy to spend such time with you. Thank you.